Okay, so let's continue with number 8. And the instructions for that question was write log equation into exponential. So we have log of 4 base 8 equals 2 over 3. And again, we have them color-coded just because that's what we've been doing in the previous questions. So again, what I will do is I will go ahead and place my general equation, which is log of x base a equals y. So in other words, now the a matches up with what number? 8, exactly. The x matches up with what number? 4, good job. And y matches up with what number? Or what fraction? 2/3, good. Okay, so then we're going to go ahead and write this into exponential form. So I'm going to go ahead and copy and paste my exponential format, which is a to the y equals x. Okay, I'm going to go ahead and set it up. So now the a matches up with what color or what number? 8, exactly. So we're going to go ahead and make that 8. The y matches up with the green color, in other words, what fraction? 2/3, good job. Let me go ahead and change that to 2/3. And then the x matches up with the purple, which is what number? 4, exactly. So we have 8 to the 2/3 equals 4. Excellent. Okay, so if you also want to make sure that that is correct, we can always type it in your calculator. So let's go ahead and find the calculator. Alright, so let me change this to scientific. So let me say 8 raised, let's see where my raised is, raised to the parentheses 2 over 3, close parentheses, and that should equal 4, which is exactly what you see right here. So this equation actually does make sense. And again, you can type this in your calculator, and you should get that the value does indeed equal 4. Okay, this time let's move to number 9. And let's go ahead and write the instructions for number 9. Number 9 instructions are write the exponential equation into log equation. Okay, so this one is actually going backwards. So I'm giving you the exponential, and this time you have to write it into the log. So if I give you the exponential, that one is, so I went ahead and wrote my exponential format. Now what I'm going to do is go ahead and give you the problem, which says 5 to the third equals 125. Okay, so at this point, again, let's match up each letter with the appropriate number. The letter A matches up with what number? 5, that's exactly right. The letter Y matches up with what number? 3, good job. And the X matches up with what number? 125, perfect. So I want to write this into a log equation. So what I do is write my format for the log, and then all I have to do from there is to match up those letters with the appropriate numbers. So here I have A, which is what? 5, good job. So that's going to be my base. X is the purple, so that will be what? 125, exactly. And then I have Y, which is my exponent in this case. And what value is that? 3. Good. So my overall answer is log of 125 base 5 equals 3. Excellent. Okay, number 14 is the next one, and that will be the exact same instructions. So we have 14. write exponential equation into log. And we have, let me go ahead and write down my first form, which is a to the y equals x, the exponential form. And that one is 4 to the negative 3 equals 1 over 64. So we have 1 over 64. All we are doing in this case is rewriting into the log equation. So if I write into the log equation, let me go ahead and write my log template. And again, before I substitute, let's go ahead and match up. The a matches up with what value? 4. The y matches up with what value? Negative 3. And the x matches up with what? 1 over 64. Good job. Okay, so then after that, all I have to do is go ahead and substitute the appropriate letters with numbers. So in other words, a in this case is what? 4. Excellent. X in this case is what? 1 over 64. Let's go ahead and place all of that in parentheses. And then we have y, which is the exponent part, and that is what? Negative 3. Exactly. So our overall answer is log of 1 over 64 base 4 equals negative 3. Excellent. Okay, so now let's go ahead and move on to something a little bit much more complicated, and let's do 31. 31 states to find domain x-intercepts. So find domain, vertical asymptotes, x-intercepts, and sketch. Okay, I'm not too concerned with the sketching. We all know that log functions usually represent some type of exponential curve, but the main meat of this problem is to find the domain VA, which is vertical asymptote, and the x-intercepts. So our first equation is, let me change this to 31 right quick. So this is 31, and we have y equals log base 4 of x. Okay, so if you remember correctly, and I'll go back to it, we had this part right here. This is the most important part. This was your general part. With the domain, the vertical asymptotes, and the x-intercepts, we're only concerned with the bx plus c part, which is the only section that is inside the what? Inside the parentheses, exactly. So that's what we're going to do. Now, to get the domain, we have to set it greater than 0. To get the VA, we have to set it equal to 0. And to get the x-intercept, we have to equal it to 1. So let's go ahead and do that with this one. In this case, I can rewrite this equation, if you want to see it in that way, as 0 plus log of parentheses x minus, is it a minus? Let me check. Plus us, so it's x plus 0. Okay, so that's what we have right now. At this point, my bx plus c part is the inside of the parentheses, which is this part right here, x plus 0. So let's go ahead and find my domain. My domain is take your x plus 0. So x plus 0 and set it greater than 0. Obviously, in this case, my domain is basically what? X is just greater than 0. Okay, so that's my domain. That's one of our answers. So I'm going to go ahead and highlight that. The next part is my VA, or my vertical asymptotes. And we have, for that one, we have to take my x plus 0 part and set it equal to what? Set it equal to 0. Okay, well in this case, what's my answer? In this case, my answer is x equals what? X equals 0, correct. So far I have x equals 0 as my vertical asymptote, and my domain is x is greater than 0. Okay, so we have to highlight this. And then our last part is to get the x-intercepts. So the x-intercepts, what happens at the x-intercepts? Of course, y is always 0. So we have to set my bx plus c part, which is x plus 0, and set that equal to what? 1. Well, in other words, if we get rid of the 0, we still have, this time, what? X equals 1. So x equals 1 will be my x-intercept. And we have that. Again, you have your domain, which is x greater than 0, vertical asymptote, which is x equals 0, and x-intercept, which is x equals 1. Excellent. Okay, so now what we're going to do is we're going to go ahead and do number 34. So I'm going to copy and paste this one so I won't have to continuously type. Alright, so here we go. Same instructions. However, my equation has changed to log of x minus 3 is log of x minus 3 base 4. So in this case, again, I don't have a shift that moves my log function up and down. So this can be 0. And here I have x minus 3. Okay, so my bx plus c is everything that's inside of the parentheses. In other words, x minus 3. So that's exactly what I am going to set my domain as. So I'm going to have x minus 3 is greater than 0. Okay, so I need to solve for x. In other words, I need to get rid of this negative 3 and move that to the other side. So how do I get rid of a negative 3? Good, I add 3. So if I add 3 on both sides, I basically get x is greater than what? 3. Excellent. So that's my domain. Now moving on to my vertical asymptotes. I still have my bx plus c part, so I have x minus 3. And I set it equal to 0. And all I need to do from here is solve for 0, so I get x equals what? X equals 3, correct. And then I have my x-intercepts. Well, what do I take? My x-intercept, I take my bx plus c and I set it equal to 1. So I have x minus 3 equals 1. I move this negative 3 to the other side, so I add 3. And what is 1 plus 3? 4. So my x-intercept is x equals 4. Okay, let's move on to number 36. 36, I'm going to try to zoom through it quickly. It's the exact same thing. So we have, so this is number 36. 36 states, same thing. We're in base 5 actually here. And we have x minus 1 and plus 4. In this case, the plus 4 is on this side, but if you want to see it in the exact same form, you can just rearrange everything and we can have the plus 4 here. So we really have 4 plus log of x minus, let me change this, x minus 1 base 5. Okay, so your bx plus c is everything that's inside the parentheses. So we have x minus 1. So to get the domain, we simply say x minus 1 is greater than 0. Solve for x and you get x is greater than 1. Okay? To get your vertical asymptote, you say x minus 1 equal to 0. Solve for x and you get x equals 1. And finally, to get your x-intercept, you say x minus 1 is equal to 1. You get rid of that negative 1 right here by adding 1 to both sides. So you get 1 plus 1, which is 2. So your x-intercept is x equals 2. So again, x is greater than 1 for your domain, x is equal to 1 for your vertical asymptote, and x-intercept is equal to 2.